Hello, hi, this is Rani Ahmed with you, and this is lesson 19 on how to program using Haskell programming language. And in this lesson, I'm going to talk about higher order functions and currying. Now, in this lesson, I had to go a little bit from outside the book, okay, just to get some functions from here and there, just to be able to sort strings, okay, that belong to a set or a list of strings. Okay, now in the book it talks about the function quick sort. Okay, and this is one of the functions that has the highest speed in sorting. Okay, and if you have seen this function in your university, you know how hard it was for you to write it in C or in Java. And you know recursion usually is hard in C and Java. So if you see it here in Haskell, kaboom, just those 6 lines and you're done, okay? Or whatever they are. So this is how the function is done. It starts with the function name, of course, quick sort. Then here there is any function, okay, which you use it to compare where things are. Okay, I'll explain a bit for those who don't know. Okay, with respect to the point or with respect to that number, okay, that you want to start with to reorder things according to it. Okay, whether it's before it or after it. Okay, and if you are ordering here as an input an empty list, of course it should give you an empty list. Okay, next, if you have a function that you're going to use to compare, okay, and you've got just a singleton list, okay, it just has one element, it will give you that singleton. Okay, now let's say I have a full list, a complete list, okay, and I want to quick sort it. See, this is our part where the real quick sorting goes. Now, C represents the function that I want to use to compare. Now, this function should be of the type ord, okay, which means order, which means or ordering, which should give me whether as a result LT for less than, okay, or equality for, you know, equal to between two members, okay, and greater than if it is greater than, of course, okay, if it gives me that the comparison is greater than. Now if I take, for example, let's start with an example here, this thing, okay, and we start with, of course, the letter W, okay, as the starting point. Now you take everything that's before the W, like A and E, you put them before the W to the left of the screen, okay, and the things like X, Y, Z, okay, put them to the right of the screen, okay, just put them randomly, don't care about the order yet, okay, this is the first step only, okay. So what will happen, I'll get, according to this part of the string, okay, I'll get E, then A, okay, then put to the left, and whatever later, like X and Y and Z, if we get them here, okay, they will be put after the W, okay. And next, on the second call of the quick sort, okay, it will start with that part, the AE, and resort it, okay, and the second part, which is greater than the W, will also go and get it sorted again, okay. Why? Because if you look here, I'm calling quick sort on the same comparator, okay, with the parts which are less. And what's less? I'm using the prelude filter, because there's a filter function inside the text class here, okay, the text part here, okay. So I'm just using the very basic filter that comes from Haskell, okay. And because I'm using things which tell me that they are less than, it will filter them out and gives me those which are lesser than X in the rest of the string, okay, or the rest of the list. Okay, so you'll be left out with the things that are bigger than and equal. Okay, and on the next on the equal part, okay, we just left with the things which are equal, okay, but you don't touch the things which are, yeah, I mean, you take the things which are equal and you leave the things which are greater and less than. And similarly here with the greater than, okay, just take the greater than and leave the less than and the equal. Okay, now you take always the less than and the more, okay, and always the result of the equal is always const in the list. Okay, and every time you call quicksort on the list and quicksort on the more, and you get a tree like structure. Okay, until you finish and reach this starting point. Okay, or this base case. Cool. So it will all the time recurs. Now what's currying now? Currying is when I say, for example, I want to use to upper from the data.text, okay, and I want to use the prelude here .map, okay, so I can map every word in that list. Okay, for example, I have this list, okay, I Linux A, and I want to make it all uppercase. Cool. So the data.text.pack should like by definition it should turn the type string to the type text. Okay, this is something required just to do a whole string conversion to upper or to lower. You can also use the to lower. Now what concerns us about the currying is that if I want to make a summary of those, okay, was like if I want to use them here instead of my convert, okay, like an alias, okay, so I could have used this way. So it can automatically, Haskell, know that has to pass X to the rest here. So as if you made an alias to my convert word, okay, and therefore here you get an X, okay. It will know by itself that has to put the rest of the parameters, okay. This is currying. Now, another thing in Haskell, okay, we can do is if I want to use this function called flip, okay, and this function takes another function with two parameters. Okay, now this is equivalent to having this this function f, okay, doing y then x, okay, instead of doing x then y. So it flips the order of or swaps the order of the parameters of the function. Okay, so for example, if I want to flip the 3 over 1 to 1 over 3, okay, I can use the flip like so, okay, to get that division of 1/3. Okay, now other thing new in Haskell I'm going to talk about now here is that this $sign symbol. This will ease for us the typing of so many parentheses. For example, if I want to do composition of functions, okay, I will have to do the very basic, the one who doesn't know anything, okay, usually in Haskell, the starter, I mean, he starts with writing function of function of function like we see here, okay, or you could have used the f.g.h, okay, the composition, then you would have to put this, okay, because the dot must take an input. I can instead use the $sign as such, okay, to give me this, but when you're converting this to a dot sign, you will have to put the last one with a $, okay, you must. This is because a dot has to take an input, okay. And that's all in this lesson. Thanks for watching. Please subscribe to my channel just to get newer updates.